So we're up to chapter 10, which is basic router configuration. So chapter 11 is when we start talking in depth about IP addressing. So chapter 10, and so we're going to implement initial settings on a router and end devices. So a bit like chapter 2, but on a router instead of switches. And so we're going to configure initial router settings. And so when it comes to passwords and other such things like that, it's damn near identical. Configuring interfaces is certainly different on a router compared to a switch, because that's where they do differ. And we're going to configure hosts to actually have default gateways. Okay, so configuring router initial settings, and so much the same as I said on chapter 2. Host name command is the same, enable secret command is the same, line console 0, line VTY. It's all very much the same. Encrypting the passwords to save from shoulder surfing, banner motd, again, it's all the same. So there's no rocket science involved in the first part of the course by any stretch. And so this is an example, of course, of what happened. The only problem I see with this is hostname R1, but the prompt was already R1, so they'd already done that apparently. But I'm going to say all works rather nicely. One thing I suppose we haven't covered on the line VTY here, we've got transport input SSH telnet. And so remember I said that you could either have SSH or telnet to connect to the switches. Well, the routers are the same. Here we're just specifying what are valid protocols. And so if you just wanted SSH, you just do transport input SSH. If you just wanted telnet, which would be rarer, you would just do transport input telnet, and away you'd go. Now, I don't think this command as it is works on packet tracer. I think you can do transport input all, and that will allow any protocol, or you can do one specific, unless in the latest update they've changed that. But in my experience, at least in the past, it didn't support two protocols. But anyway. All right, so how do we configure router interfaces? And so again, it's probably a bit more like how you did the interface VLAN 1, but on a switch, you know, it's always going to be interface VLAN something. On a router, it actually depends on what interfaces are installed on that router. And so as you can see here, it says interface type and number. And so if we're going to configure the gigabit interface, it'll be interface gigabit Ethernet 0/0 or whatever it might be. And then a description you can actually put in. And so that doesn't actually achieve anything in the way that the router behaves, but it is useful for if some other tech has to come and support that device, that they'll actually understand what this interface is used for, what network it connects to, or whatever it might be. So that's the reason for the description. And then from there, you can set an IP address, you can set an IPv6 address, and of course, we turn it on with that no shutdown command. All interfaces on a router are layer 3 interfaces, so they're turned off by default. And so you need to turn them on with the no shut command. And so as it says down the bottom, it's good practice to use the description command to add information about the network connected to the interface. And of course, the no shutdown turns it on. Okay, so here is an actual example. And so we're on router 1, and we're configuring interface gigabit Ethernet 0/0. And so you can see that the prompt changes from global config mode to interface config mode, and then description to LAN, description link to LAN. Now, LAN is not necessarily a great description. Of course, this is a theoretical example, and so it could be sales LAN, or admin LAN, or student, or staff, or whatever it might be, guest. Just the descriptive name so that you understand which one it is. And then you can set an IPv4 address with its mask. You can set an IPv6 address and it's prefix length, and then you turn it on. And then you actually get the messages saying, well, the interface has changed state to down. Because when a interface is shut down, it's actually not down, it's administratively down. So it thinks that a human has turned it off for a reason, and so that's why it's administratively down, so it's intentionally down, I suppose. And then when you've changed it out of that, it says, oh, okay, well, I'm not administratively down anymore, I'm just down. And then once it's had enough hello signals over the network, it'll go, oh no, I'm up. And so then it'll change like that. And so that's the physical layer, and then this is the line protocol, means that the data link layer is up as well. Okay, so this is the next interface. And so it's doing this one here. And so, yeah, so you can see the IP addressing linked to R2, and yeah. I suppose the only thing is it's a different physical interface, 001, which of course is what's on the diagram here. That one was 000. Now, gigabit Ethernet, I don't think I've ever typed that. G is enough. G000 will do the trick. G001 will do it as well. Or you could just do G and tab if you really want to get technical, but yeah, good old abbreviation. So once you've configured the interfaces, you can actually check their status by using show IP interface brief. And as you can see, you actually get a one line per interface telling you its status. And so it tells you the IP address for each interface. Is that okay? Yeah, cool. How was it configured? Manually. And so, you know, it's a static IP address that we typed into it. Sometimes you can have a DHCP address. Normally that would be a link to your ISP or something. You might actually have to set it as a DHCP client, but yeah, that's rarer. Status is up, so that's physical layer is up, and the data link layer is up as well. So there's this other interface that doesn't have an IP address, and you can see that its status is administratively down. So that has a shutdown in it. There is also show IPv6 interface brief, and that gives you the IPv6 addressing. We will go into more depth about IPv6 a bit later, but you'll notice that it's got two IP addresses. This one is the global unicast address. So that's it. Oops, oh, bloody hell, I was trying to select it. And that's equivalent of a global IP address here, you know, a public IP address. This one here is what's called a linked local address, and we'll talk about that later on. Okay, so how do we verify our commands? So show IP interface brief, and then of course you can throw a v6 on the end as well over the IP. Because it's a router, you might want to do show IP route, and that will of course show the routing table for the router. And then this of course show IPv6 route. And then there's show interfaces, which is all of the information about an interface. And so show IP is mostly about layer 3, while show interfaces gives you absolutely everything about every interface. And then there's show IP interfaces, which does more statistical stuff. Okay, so again, we're giving an example of the show IP interface commands. Show IP route. So this is the routing table. I think we've seen this previously as well. Now they've actually omitted the table at the top that explains the source information for each of these routes. If you remember, C means it's a connected network. L means it's the local address for that interface. And so with modern versions of the iOS, you get 2 entries. And so this is an IPv6 routing table. And so again, the C and the L means the same thing. Show interfaces, gigabit 000. As I said, This tells you absolutely everything about that interface. It doesn't tell you the IPv6 address for some reason. I would have thought they would have changed it a little bit, but no, they haven't. And so MTU, I think, was mentioned in a previous chapter. Maximum transmission unit, 1500 bytes is the largest packet it can send. Bandwidth, because it's gigabit, it should be, it's 1 million kilobits. So it's a billion bits. Delay is basically how long it takes a packet to cross a network, and reliability and load and things like that. And so it gives you a whole pile of different information about that interface. All very nice. Some you'll use, some you won't. Show IP interfaces is more about layer 3 stuff. And so show IPv6 interface, again. Okay, so configuring the default gateway. So the default gateway is used when a host sends a packet to a device on another network. The default gateway is generally the router interface address attached to the local network of the host. To reach PC3, PC1 addresses a packet with the IPv4 address of PC3, but forwards the packet to its default gateway, which is G00 on router 1, 000. The IP address of the host and the router interface must be in the same network. So this is 192.168.10.1 and 10.10 for the host. So default gateway on a switch. A switch must have a default gateway address configured to remotely manage the switch from another network. To configure a default gateway on a switch, you do IP default gateway and then you specify the address. So as far as layer 3 is concerned, a switch is just another host. That's all it is. And so it doesn't know how to route packets to different networks either. And so it needs to know its gateway. So of course, in that instance, if we go back to this diagram, if someone's sitting on PC4 wish to administer this switch here on a different network, as long as this knows its gateway, it can, of course, route its packets via the gateway to the switch. And then the switch, of course, needs to know its gateway so it can route the packets back to PC4. And so, yeah, and so that is it for the chapter. So what did we look at in this chapter? We did look at making settings for several devices, several settings on the routers, most of which are the same as what we did on switches in chapter 2. For routers to be reachable, the router interfaces must be configured. So the no shutdown command turns on the interface. The interface must also be connected to another device, such as a switch or a router, for the physical layer to be active. There are several commands that can be used to verify interface configuration, including show IP interface brief, or show IPv6 interface brief, show IP route, show IPv6 route, show interfaces, show IP interface, and show IPv6 interface. For an end device to reach other networks, a default gateway must be configured. The IP address of the host device and the router interface must be in the same network. A switch must have a default gateway address configured to remotely manage the switch from another network. To configure an IPv4 default gateway on a switch, use the IP default gateway IP address configuration command. So I will demo this, all this stuff. So that's the logo for the end of the chapter. All right, so I'll get that out of the way. I might just go back to that diagram that was towards the end of the chapter. I'll go to this diagram here, and I'll make that happen in Packet Tracer. So we need a router first. We need 2 switches. And some hosts. Actually, I probably should use a different router. Make it more like the all right, now we've got to cable it, of course. So these will all be straight through Ethernet cables, so the solid black. Now, I might address the host first, just because it can be done and I can get it out of the way. So that was 192.168.10.10, and the router is .1, 192.168.10.1. That's that one. This one here, 192.168. Did I? Yeah, I missed the dot, didn't I? 10.11, 192.168.10.1 for the router. I might just put a comment up here. One 192.168.11.0/24. Oops. And so this is 11. 192.168.11.10. 192.168.11.11. Whoops. No. Getting over eager. 192.168.11.11. 192.168.11.1. Okay, so that's the hosts all addressed. It's a good start. So let's start playing with the router. So if I go, of course, EN will get me into privilege exec mode. If I do show run, we'll see what's in there. And there's a shutdown command in all the interfaces. And there's very little else. So I'll go back to one of the first slides. So I was talking about these commands here. So of course, so conf T or configure terminal, host name R1, I'm assuming it's called. That'll do. What else are we doing? So enable secret class, line console 0, password Cisco, log in. Now you'll notice with routers, they normally, you can actually do 0.15 and it will work, it won't complain, but normally most routers only have the 0 through to 4. Not exactly sure about the reasons for that, but that's just the way it seems to happen. VTY, 1, 2, 3, password, 1, 2, 3, login. So that's all our passwords done. We could probably encrypt them straight away. Okay, and there's banner mot D we haven't done yet. Yes, I spelled it American. Don't think there was much else, was there? Oh, line VTY, wasn't there? It was actually looking at the oops. And so the command was transport. And so there's going to be input or output, but we always do input. And see what the options are. So there is all non-SSH or telnet. Now, let's do telnet SSH, see if it does accept both. No, it doesn't. So it hasn't changed. And so yeah, you could do all, which would have roughly the same result. But yeah, so that's one other thing that I hadn't covered. All right, now we're up to addressing, aren't we? So interface G 000, and so we're in interface config mode. You can do description subnet 11. No, sorry, it's 10, isn't it? This one. Ah, typo. Decryption. So IP address 192.168.10.1 255.255.255.0. And then no shut. If we go, gotta love up arrow. So just up arrowing, editing the commands, and no shut. All right, so that's actually configured it. So end show running config, and you can now see that service password encryption has been put in. I've set a host name, I've set the enable secret, I've got gigabit 000 configured with an IP address, gigabit 001 with an IP address. We've got the banner mot D, and we've got the lines configured with passwords as well. Of course, show start, not yet. So I've got to do the copy run start so that it can reboot and still have a configuration. All right, let's have a play. So, of course, this is 1010, this host. Suppose we could IP configure it to make sure. And so its address is 1010. The gateway is 10.1. Let's ping the gateway, 192.168.10.1. Isn't that nice? The gateway is responding. The other host is 11, isn't it? We can always ping that one as well. That's working nice. So the local LAN is good. Can I ping to the other LAN? Because, you know, from PC 0 to PC 2 or 3. And so let's try that. Might be a little slower. Might be an ARP request or two in the process, but there we go. And so 1110. Eventually, there we go. Now, there's still a couple of things I haven't done. I haven't done the switches at all when it comes to addressing. And I also haven't done IPv6, but anyway. So let's have a quick play with the switches. En conf t interface VLAN 1 IP address. Now this is the top one, I'm assuming. Yes. 192.168.10.1 10.2 will do the trick. No shut. All right, so I might just minimize that. So I'll ping that IP address from this host. Now again, as I think I said previously, the switches seem to be a bit slower at responding to WARP requests, but that works. Now PC1 can ping the switch. Of course, they're on the same subnet or network. So switch 0 is working, but I haven't set a gateway yet for it. And so this PC3 actually won't be able to communicate properly with the switch. So let's try pinging it, 192.168.10.2. Now the packets will actually get to the switch because PC3 can communicate with the other route, network. But the switch actually doesn't know what to do with the packets to send them back because I haven't told it who its gateway is. And so they're just going to fail. So let's get the switch up again. And so, yeah, that didn't work well. Exit. Now IP default gateway 192.168.10.1. Now I tell it who its router is. It should actually work. So let's try that again. And yeah, the switch had to send out an ART request for the router because they hadn't spoken to it before. But yeah, now that's working. And so that's why the gateway setting is so important. So yeah, I haven't done all of the switch, but you know, a lot of that would have been repetitive. But if we do show run, I've set up the addressing on interface VLAN 1. I've told it who its default gateway is, and that's enough for it to be able to talk. I haven't set up the VTY lines yet, so I can't actually telnet into it. But you'll notice that there's actually the login command there by default, and that's a bit of a security measure. And so I could actually try to telnet into that, and I'll just get a nasty message back saying sorry. So 192.168.2.10, and it won't work because the login command in there says I want people to log in, but there's been no password set, and so it goes nah. And that was a little more severe than I was expecting. It just disappeared. Okay, so the current session is closed. Yeah, so it just didn't work. Sometimes, depends on what client you're using, sometimes you'll get a password is required but none is set. Well, whether that was an older version of the switch software, I don't know. So that's actually a message I've gotten back from it. Okay, no password. So if I go into this and I go, so conf t line VTY 015. Typos again. Password Cisco. And now that actually should work. .10.2. And so now I can actually log in and do remote stuff. I haven't set an enable password yet, so it's actually preventing me from getting in because I haven't set one. It doesn't trust Telnet. I don't know why. So anyway, now IPv6. Now I've got to come up with an addressing scheme off the top of my head. Let's steal the one they used. Do they have one? Okay, so conf t int g000 IPv6 address, and yes, I'm a thief, and so I just copied it out of the PowerPoint, and so we haven't really gone into any great depth into IPv6 addressing, but I think we have covered that between each of those colons there's 16 bits. Now you can actually abbreviate addresses, and so that's what these two colons are. And so basically it will fill that gap completely with zeros. That's how that abbreviation works. And so we're just using address 1 for the router. And so it's a CAD 10, that's its subnet number, and then 1 is its host number. So if we hit enter there, that's nice. G001, let's go there. And of course this will be 11. And that will work nicely. Now there's one extra step. I've set the IP addressing on the router, and that's nice. But by default, IPv6 routing is not turned on. And so it didn't actually cover in the slideshow. I'm assuming it might have in the chapter. But there is actually a command I have to do. So exit, back into global config mode. So there's IPv6 unicast routing. And that actually turns the routing function on for IPv6. Now the host will actually be able to route through the router. Before you do that, the router is just an IPv6 host. You do that IPv6 unicast routing, it becomes an IPv6 router. All right, now there is a wonderful thing about IPv6. Now that I've got a router on, I can just say, oh, let's figure out our address automatically, and it has already. It's a very nice function, that. And so that could work perfectly well. Those hosts will be able to talk. The only bit of information it's missing is a DNS server. And so that is a very nice function. It's called stateless automatic configuration. Just turn it on to automatic. And it, remember, briefly for ICMP, it's mentioned router solicitation and advertising messages. That is actually what the hosts do. And they say, who's my router? And then the router says, I'm it. And by the way, you're connected to network such and such. And then the host then figures out its own host number, and it can connect. So that's all you really need to do. And so these hosts will talk very nicely, thank you very much. About the only problem with them is, that's a really ugly address. So what I might do is I might actually, no, you don't put in a, now that's the gateway address. Oh, this is 11. So I've actually done a static address. The reason I've done that is it'll be a lot easier to ping. So copy. So I'll actually ping it from this other side. Paste. Might be an ARP request or two. Ah, you dork. Wrong address. I didn't edit enough. It should have been 11 in the second last number. Now I'm going to have to check that other host, see if I got it right. No, I didn't. Yeah, trying to be too clever for my own good. All right, the last one worked because the address had been fixed. That's better. Too much cut and paste. But anyway, so so that's IPv6 pinging across the router. So I'm gonna say, apart from the reason I pasted the addresses is I really hate typing them for IPv6, but I'm going to say it does have many improvements over IPv4. So that's pretty much what the slideshow was getting at. So just about how to configure a router is the major thing. And so, yeah, so from here on in, I'll get you guys to do some labs that are in chapter 10, and we'll be able to carry on from there. So, yeah.